All right, guys and gals, let's take a look at homework. So we're going to start with some ratio tables. Dante's decision. So he's got 20 bucks and he's got a choice to make. Does he want to get some baseball cards? Each pack costs $1.70. He can also get some gum. That's 60 cents a pack, sorry. Or he can get some bouncy balls. Those are $3.15 a pack. So first, just reviewing this idea of ratio tables. Let me see. Go a little thinner than that. You know, one place that we can start is, honestly, let's look at the 10 first. Let's jump around a little bit. You know, all of these do have a 10 in them. And in class, you know, we talk about if we're multiplying a number with a decimal in it, every time we multiply by a power of 10, we're just going to move that decimal over one spot. So now it's going to be behind the 7 there. So we're going to go whoop. Now it's going to be right here. So it'll be 17. Technically it'd be 17.0, but since it's money, we can just say 17 bucks, right? Again, if we move this decimal here, it's going to go behind the 6. So this would be $6. And if we move this one here, we're going to get 31.5 or 31.50. So just keep that in mind when we multiply a number with a decimal by a power of 10. We just simply move that decimal over. So that kind of gives us a good place to start. You know, and then like we also have 20 on a couple of these. So now that we know what that 10 is, you know, we went from 1 multiplied by 10. Now we can go from 10 and we can multiply it by 2. So I know I can double that. I got to do the same to my bottom. So if I double that 6, now we've got 12 here. Okay? How about over here? Well, 10 times 2 is 20. So then we're just going to have to double whatever this is. Well, if I have $31, if I double that, we're going to get 62, right? Double my 30 to get 60, double my dollar to get $2. Double 50 cents, that's going to be one more dollar. So altogether, we're going to get 63 right there, right? So the idea is just kind of use your facts to jump around how you want on here. So we got a 63 there. You know, some other things on here we can do. Again, if we know 1 is $1.70 for these baseball cards, I can double it to get 2, right? Just double it. So think about what's $1.70 plus $1.70. You know, if you want to, you can even just kind of add these up over here. Whatever you need to do. Get a 14. Looks like 340, right? Then we're going to do it again. We can just double it again. Because to go from 2 to 4, I double it. So guess what? We're going to double that 340. Well, if I double $3, that's $6. Double 40 cents, that's 80 cents. So it looks like that's going to be $6.80. And then just keep going from there, right? So just practice that idea. Once we kind of hop on this double train, just keep riding it, right? To get 9, well, if we know this was 10, we could subtract 1, and that would tell us how many 9 would be worth, and kind of go from there. And then for the packs of gum, one thing we can do also is we can jump back and forth. So let's jump backwards on this one. Again, 1 pack of gum is 60 cents. We multiplied it by 10 to see that 10 packs would be $6. What if I want to go from 10 to 5? I can divide by 2 to get to 5. So guess what? We just got to divide by 2 here. So half of 6 is 3. So that tells me, oh, okay, so 5 packs of gum would be $3. So again, whatever relationships we can find on these, you know, to get 25, well, we know 20 was $12 we found out. 5 packs were $3, so I just got to add the 12 plus the 3. So again, just practice those ideas. You know, with the bouncy balls, again, we can kind of double it to get to the 2. How about 3? Well, let's do this real quick. So if we do double this, well, if I double 3, 15. If I double 3, that's 6. And double 15, we're going to get 30. Okay, cool. And then how do I get 3? Well, 3 would be if I added 1 pack plus 2 packs. That gives me 3 packs. Oh, so I just got to add the 315 plus the 630, and that tells me the price here. Okay, so $3 plus $6, that's $9. 15 cents plus 30 cents, that gives me the 45 cents. Okay, double that. So just practice, and again, feel free to use your scrap paper. Use it on the edge of the side here. Whatever you got to do, guys, just work it out. We can work it out. Then down below, we got a few other questions. On these, he's got $20 he wants to spend. Can he buy 12 packs of baseball cards? Well, let's go up to baseball. Notice how 12 wasn't one of these. Hey, but look right here. We found out what 10 was. We found out what 2 was. So 10 and 2, that makes 12. So let's see, 17 plus 340. Okay, so we just got to add the $17 and the 340. We got that from up here. Does it look like he's got enough? Will $20 be enough? I don't know. Figure it out, guys. How about 30 packs of gum? Well, again, we figured out how much 10 packs of gum was. That was 6. And the 20 packs, that was $12. So we just got to add the 6 plus the 12, right? So that was $12 plus $6. And then how much of the $20 will he still have left after he buys 5 packs of bouncy balls? So now we know he's got enough, because the question is how much money will he have left? So 5 packs of bouncy balls. Well, again, we didn't find out how much 5 packs of bouncy balls were, right? But let's do this. I know 2 plus 3 will give us enough. So to find how much 3 packs of bouncy balls are, I got to add the 1 plus the 2, right? So again, we already talked about this, but let's do the work over here. This is going to tell us how much 3 are. So you get a 5, 4, so 945. So 945 is how much 3 packs of bouncy balls are. So in order to find 5 packs of bouncy balls, I got to add 2 packs plus 3 packs. So 630 plus 945. So 630 plus 945. So if we add that, that'll tell us how much those bouncy balls cost, and then we're just going to have to subtract from there. So I think we got enough set up for you. Let me know if you have any questions, but we'll keep rocking and rolling here. Up next, we're just reviewing our numbers a few different ways. Base 10 numerals just means write the number. So whatever the regular number would be. So 3,000 plus 60 plus 4/10 plus 2 thousandths. So 3,000 plus 60, well, that's 3,060. Then we got 4/10 and 2 thousandths. So I noticed we didn't have any hundredths on that one. So just keep that in mind. If there's nothing for that place value, then just it's a 0. 117 and 3 thousandths. So 117. And think about how we'd write 3 thousandths. Write the word names. So now we're writing some words. Let's get the typing tool so you don't have to read my chicken scratch here. We'll go ahead and do this first one. There we go. So 300 is the only whole number. So this is going to be 300. There's no more hundreds, no more ones. We got 1/10 and 4 thousandths. So for just a second, we could think about, well, that's cool. Let's see if I can go back and forth between these. I don't know. Might have to do some undoing. But let's just write this real quick. So that's 300. We got 1/10 and 4 thousandths, so there's no hundredths. So that's the actual number, 300 and 104 thousandths. Cool. So we got 300 and 104 thousandths. Thousandths. Whoops. Kind of got to lift my hands, get on my Chromebook here. So 300 and 104 thousandths. That's how I want to think about that. Remember, the and is where the decimal goes. And then next we're writing in expanded form. And again, our example here is they give us this number. So 642 and 835 thousandths. So what's that 6? Well, that's 600. And we'll just kind of drawing tool. Yep. So again, that 6 represents 6 times 100, right? Or 600. You know, this 4, that's in the tens spot, so 4 times 10. And that 2 is just in the ones spot, so 2 times 1. You could think, well, it's just 2, but yeah, it's times the ones place, right? And then the 8, that's in the tenths spot, so 8 times 1/10. 3 is in the hundredths spot, so 3 times 1/100th. And I guess we'll go black. Sure. 5 is in the thousandth spot, so 5 times 1,000th. So again, we're just kind of breaking those apart. So 400,053 and 296 thousandths. This tells us where the decimal is going to go. So 400,053. I'm sorry, 4,053. Hey, what time is it? 5:30? After having some PD today. 4,053 and, so 4,053. 4,053 and 269 thousandths. So ands are going to be our decimal. 269 thousandths. 269 is what we're looking for on that. And again, we're just going to break it apart like we did. So that's 6 up here. So now we have a 4 in the thousands spot. So 4 times 1,000. And then we got, now there's 0 in the hundred spot, so we don't have to write that at all. I'm just going to skip that. If you want to write 0 times 100, that's fine. Then we got 5 times 10, because that's in the tens spot. And then this 3 is in the ones spot, so 3 times 1. We have our decimal, so now we're in the tenths. Zero 0.1s for the tenths, yep. And then 6 is in the hundreds spot, so 6 times 100th. And then lastly, we get a 9, and that's in the thousands spot. So just like that. Cool. And then do the same down here. B has basically the same number of digits, except that does have 1 in the hundreds. So 9 times 1,000, 6 times 100, 1 times 10, 5 times 1, right? 2 times 1/10, 4 times 100th, 5 times 1,000th. So just think about what does each one of those numbers represent. Less than or greater than. Again, just like in class, we talk about just start at the beginning. It's all about place value. It's kind of like ABC order, alphabetic order, except with numbers. So we start, we got a 4 in the tens, 5 in the ones. So we have 45. So that doesn't really help us. Think about money if you want. If I have $45.01 or $45.10, we can see the 10 is going to be more. And mathematically, it comes down to we have a 0 in the tenth spot or a 1. So the first time we get to a number that's bigger, it's bigger. Doesn't matter if it's got more digits past it. That has nothing to do with it. It's all about place value. Yeah, I'm just kind of looking at these. Keep that in mind, guys. We'll go ahead and let's take a look at this last one. So think about 70 and 0, right? So I got a 7 in my 10 spot. I don't have anything in my 10 spot, so it's kind of like a 0 here, if you really want to think about it. So clearly 70 is more than 0. And then we got 0 in the 10s and a 7 in the 10s. But again, since we had a 7 in the 10 spot and we didn't even have anything in the other 10 spot, clearly that's more. Okay. Next, we get up to a challenge. Again, we talked about in class, this isn't really that big of a challenge. Just think about what we're doing here. All right, Abby's going to make some tie-dye t-shirts for her class to wear on a field trip. Each shirt costs $3.95, and the dye for each shirt costs 50 cents. Abby also needs to buy 2 boxes of salt to add to the mix for $4.50. So she collected $124.70. How many tie-dye shirts can Abby make? Show your work. So really what we're thinking about is how much is each shirt going to cost? So we got to buy the shirt and the dye. And then we're just buying 2 boxes of salt for the whole project. So we don't need to buy a box of salt for each shirt. So one way to start is, well, we know we've got $124.70. Okay. A couple things we got to do. We know we got to get rid of our salt. So how can we figure out how much the salt is? We got to get 2 boxes of salt for $4.50 each. So we're going to have 2 times $4.50. Okay. So first, we're going to start with how much money we have. We got to get rid of our salt, right? And then we're going to see how many shirts we can make. So we're going to do some division. But how can we figure out how much our shirts are going to be? Well, they were $3.95 for the actual shirt, but we also got to add 50 cents to each shirt for the tie-dye, for the dye. Okay, so it looks like there's a lot going on. Let's just break it down a little piece at a time. Anytime you get to one of these problems, guys, just break it down. Let's kind of do it over here. So let's talk about how much this salt is going to cost. So 2 times $4.50. You might be able to do it in your head, right? 2 times 4 is 8. 2.50 cents is another $1, so it looks like 9, right? If you want, you could also just add $4.50 twice. Get a 0, get a 10, 8, 9. Okay. So then we're going to have $124.70 minus $9. Okay. And then how much is each shirt going to actually cost? Well, we said it was $3.95 plus 50 cents for the dye. So we got a 5, 14, $4.45. Okay, so we're getting somewhere. So let's see how much money we have after we're done buying the salt. So we're going to have to do $124.70 minus 9. And just remember, where's that decimal go? Right there, right? So we got 70. 4 minus 2, we can't do that. 14 minus 9. 4 minus 9, we can't do 14 minus 9. We got 5 left over. So we got $115.70 is how much money we have. And we know each shirt costs $4.45. So we got to figure out, how many times does $4.45 go into $115.70? And, talked about, really we're just doing division here. And we haven't really talked about decimals with division in class, so we just, talked about what can we do, and they're like, well, we could take 10 shirts. We can definitely do 10 shirts. So we can break this up with partial quotient. How much would 10 shirts be? Well, again, we talked earlier, we're just going to move that decimal over. So 10 shirts is going to be $44.50, right? So we do $44.50 50. That'd be 10 shirts. So subtract. Can't do that. And then 11 minus 4, we get 7. So we still got $71.20 left. Hey, we can do another 10 shirts, can't we? So 10 times that, again, is going to be $44.50. I have to do some regrouping here. 12 minus 5 is 7. We got 0 there, so we're going to have to regroup. Now we got 10 minus 4, which is 6, and 6 minus 4, which is 2. Okay, well, we can't do another group of 10, can we? But what about this $44.50? What's half of that? Can we take 5 shirts? Half of 44 is 22. We got 26, and then a quarter. Okay, let's do that. Let's do 5 shirts. Again, all we did is we knew 10 of shirts were $44.50. So 5 is going to be half of that. What's half of 44? 22. What's half of 50 cents? 25 cents. Cool. So we can do 5 shirts. That's going to be 22.25. So we get 0 minus 5. Can't do that. So 10 minus 5 is 5. 6 minus 2 is 4. 6 minus 2 is 4. 2 minus 2 is 0. We got $4.45 left over. Hey, that's enough for one more shirt. And if we take that one more shirt, we'll have no remainder. So if we take a look up here, we took 10, 10, 5, and 1. Trying to see if I can try to keep it somewhat organized here, right? So 10, 10, 5 is 25 plus 1 is 26. So 26 shirts. So here's the deal. Did that take a minute? Yeah. Was there a few steps? Yeah. But have fun with it, guys. Break it down one step at a time. So, 26 shirts. And again, that's kind of how we got there. All right. Rest of this stuff, we're reviewing some multiplication. Maria's practicing. She knows the first step, then she gets stuck, finish these problems. So Maria is just starting with our very first step. We're doing 8 times 8 is 64. And we'll help her out a little bit. So first, remember, we're going to multiply with whatever this is. So 8 times 8 is 64. 8 times 3 is 24. 25, 26, 27, 28, 29, 30. Okay. And up next after that, we're done with that first round of multiplication. Next, we're going to place a 0. And by the way, we know our answer is 1,064. I did put the final answers. And then up next, we got this 2. So 2 times 8 is 16. 2 times 3 is 6, plus 1 is 7. So we're done with multiplication round 2. And then finally, just add these up. So we got a 4, 6, and a 10, 1,064. Okay, again, that's the idea there. Just multiply 0, multiply, add, and you're good to go. Number 3, Conrad likes to use the standard algorithm. He has to solve 99 times 38. Can we recommend another strategy? Again, in class, we talked about, hey, you know what? If you're multiplying by 99, that's really close to 100. So instead of doing 99 groups of 38, we could do 100 groups of 38. Because multiplying by 100, we're just going to place a couple zeros, right? But since we went over one, we went one too many, we're going to have to take away a group of 38. So that's the answer. You don't even have to solve it. We just want to talk about that strategy, right? So if you're around a friendlier number, you can make it a friendlier number, and then we just got to either add or subtract, depending on what you did. And then again, standard algorithm for 825 times 32. Just remember, whatever your final answer is, you're going to have to move that decimal 2 places. because we've got 2 places past the decimal here. So just solve it like you normally would without worrying about the decimal at all. But then when you're done, you're going to move the decimal 2 places to the left. And the final answer is 264. Technically, you're going to get 264.00, but we don't really care about the 00 at the end. We'll talk more about that in class, but that's what we're thinking about that. All right. So we've talked in class with our February number corner about kind of finding these rules and functions and finding what numbers would be next. So this is kind of an input-output chart, basically. So we're going to use this formula, and if I put in a number, what kicks out? So think about kind of like a little machine. You know, if we are using that formula, 2n plus 1. Well, what if n equals 1? What if n equals 2? What if n equals 3? You know, what if n equals 4? And that's what these mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You would go all the way to what if n equals 10? Well, what if n equals 1? That means we're going to put a 1 in for 2. Or I'm sorry, put a 1 in for n. So 2 times 1 plus 1. So 2 times 1 is 2. Plus 1 gets us to 3. And that's where that 3 comes from. Okay, what if n equals 2? Well, 2 times 2. All we're doing is putting these numbers in for this n right here. So all we're doing. We have to write the rest of it. So 2 times 2 is 4. Plus 1. What's 4 plus 1 is 5. That's where that comes in. Okay, what if n equals 3? Well, 2 times 3 plus 1. 2 times 3, I'm putting a 3 in, so 2 times 3 equals 6, plus 1 equals 7. So we're just getting a 7. Okay, what if n equals 4? What if I say 2 times 4? All we're doing is we keep putting a number in. Instead of an n, let's try a 4. 2 times 4 plus 1. Well, 2 times 4 is 8 plus 1. 8 plus 1 is 9. Now, you might notice, is there seeing a pattern here? Are we just kind of adding 2 each time? Once we started at 3, then we're kind of just adding 2 each time, right? That's the idea there. And then the same is true for number 6. This time we're using this formula, 4n plus 1. And I'll just kind of, again, what if n equals 1? What if n equals 2? What if n equals 3? What if n equals 4? And technically, you have to solve all the way to what if n equals 10. Can I? I think I can, right? Should have slid this over a little bit. There we go. So again, all we're doing is plugging in a number for this n here. Okay, so for the first one, 4 times 1, because we said what if n is 1, plus 1. Well, 4 times 1 is 4. 4 plus 1 is 5. That's where that 5 came from on that one. What if n is 2? I'm going to put a 2 in instead of this n. 4 times 2 plus 1. Well, 4 times 2 is 8. Plus 1, that gets us to 9. That's where this 9 came from. Okay, what if n is 3? I'm going to put a 3 in here for n. 4 times 3 plus 1. Well, 4 times 3 is 12. Plus 1 equals 13. So our next number would be 13. And then again, what if n is 4? If I put a 4 in instead of this n, that's going to be 4 times 4 plus 1. 4 times 4 is 16. Plus 1 gets us to 17. So again, are we kind of noticing a pattern again? If I am at 5, how many did I add to get to 9? Does it also work to 13? Does it also work to 17? Oh, yeah. So basically, we're starting with a number, and then we're just adding the same number from each one out. So this one, we're just kind of adding 4 each time, aren't we? Up here, we said we were kind of just adding 2 each time. So you don't have to show your work for every single one of these, but that's what the idea is. Once you kind of get the pattern down, then, oh, okay. And then what do you notice about these number patterns that we completed? How are they similar? How are they different? One thing, what do you notice about the numbers? Are there only certain numbers that we're seeing? Turns out they both have odd numbers, right? So, okay, so these patterns happen to only have odd numbers. You know, in the first pattern, we start with 3, and then we add 2 each time. This for number 6, you know, we start at 5, and then add 4 each time. So, just kind of what are you noticing about these patterns? And we'll talk more about patterns this year, and especially as you get into higher level math. But well, we can even put that here. What, some text. In the first pattern, you start at 3, then add 2 each time. And then what do we notice? Oh, pattern. Oops. In the, again, I gotta kind of raise my hand the way my Chromebook is. In the second pattern, you start with 5, then add 4 each time. So again, just think about what we're noticing in these patterns for now, and kind of go from there. Number 8, multiplying with powers of 10. So again, like we've talked about, if I multiply by 10, we're just moving our decimal over 1 time. So I'm going to write my 8.7 here each time. Because all of these are starting with 8.7. So if I multiply by 10, I move it 1 spot, so it's right there. So that's going to equal 87. 100 has 2 zeros, so I got to move it twice. 1, 2. It's going to wind up right here. And since there's a gap, I got to put a 0 there. So that's going to be 870. And 1,000 has 1, 2, 3 zeros, so I got to move it 3 times. 1, 2, 3. And again, I got a couple gaps, so I just got to put some zeros there. 8700, so 8,700. And again, 10 only has 1 0, so that's why I move it once. So if I multiply by 10 or larger places of 10, just move it how many zeros you have. Now, if I multiply by decimal, now that it's less than 10, same idea of moving our decimal, but now it's going to get smaller. So now we're going to move it to the left. So however many places right here, that's 1. So now we're going to move it 1 the other way. Now we're going to go this way with it. So that's going to be 0.87. Okay, how about this one? We've got 1, 2. There's 2 places. So now we're going to go 1, 2. So it's going to be a 0 here. 0.087. Okay, so again, multiplying by powers of 10, if they're larger than 10 or more, we're getting larger numbers. If it's less than 1, if it's 1/10, 1/100th, 1,000th, we're still moving the decimal, but they're getting smaller and smaller each time. And that's really what we want to think about is, right here. What do you notice? When you multiply by a whole number, power of 10, you move the decimal to the right, the number of zeros in that power of 10. So, whoops, yep, there you go. So when you multiply, thank you, by a whole number, power of 10, you move the decimal to the right by the number of zeros in the power of 10. And we got a lot of green going on. Let's change this to blue or something. How about, right? Just change it up a little bit. Okay. Now, that's if it is, actually, we'll do a couple of colors here. So that's if it's larger, right? Now, for D and E, what if it's less than 1? If it's less than a whole number, we're kind of doing kind of the opposite, if you want to think of it. Drag this over here. So for that one, when you multiply by a power of 10 less than 1, you move the decimal place to the left the number of digits past the decimal. So similar idea. When you multiply the decimal, when you multiply by a power of 10 less than 1, so smaller, right? You move the decimal point to the left by the number of digits to the right of the decimal. In other words, kind of how far over we had to move it, right? So if there was one number passed, we moved it one time. If there was two places passed, we had to move it twice. Okay? So if we're getting larger, we're getting larger each time. If we're getting smaller, you're just getting smaller however many times you had to move it. Then let's just end with a little more multiplication practice. Again, those are your final answers. For 2, filling in those missing boxes. And then number 3, Alexis has a treasure box. The treasure box is a rectangular that measures 8 by 12 by 25. Your standard algorithm to determine the volume of the box, show your work, and include your units. So for this one, we just have to do 8 times 12 times 25. And I haven't talked in class. You don't have to. Yeah, you don't have to use a standard algorithm. I'll just type this up. Because in class, when we multiply by 25, the double and half strategy can be really helpful too. So you do not have to use the standard algorithm. If you want to, you can, but I'll let you choose. If you got a different strategy you want to do in this one, that's fine. Because really, 8 times 12, that's one that we should kind of know from working on our math facts, right? So we get 96. So then we have 96 times 25. And then we can double and half that 25 till we get to 100, actually. So we've talked in class, if you want, this 25, if I double it, that makes it 50. And if I double that, that makes it 100. So now I just got to cut 96 in half and do it one more time. So if I cut 96 in half twice, then I'm just going to multiply something by 100. So if you want to do it that route, feel free. Or if you'd rather do standard algorithm for, you could do 96 times 25, standard algorithm. I'll let you guys pick what you want to do for that one. Last page, again, just kind of reviewing some skills. What's half of 84? What's 1/4 of 84? What's 1/8 of 84? So we're kind of cutting it in half each time, right? So I got to do 84 divided by 2. If I know what that is, I can cut that in half. Or I can think about 84 divided by 4, and so on. And I will even give you a little hint. I'll even throw you this one. You are going to get a decimal on C, so there will be a decimal. It's going to include a decimal on that. And then what's half of 62? I'm sorry, no. Half of some number is 62. So think about what number, what number, if I cut it in half, will get me to 62? How can I figure that out? I guess I got double 62, don't I? If I double 62, we'll get that number, then cut in half, get to 62. Okay. 1/4 of some number, so here we're going to have to do 62 times 2, right? 1/4 of some number is going to be 31. Well, that's going to be 31 times 4, right? Whatever 31 times 4 is, that's going to get me there. And you might notice another relationship that you could use as well. Let's get started. Let's look at A. What's half of 84? Well, what's half of 80? That's 40. Okay. And then what's half of 4? 2. So 42, right? And we can check. If I add 42 plus 42, does that get me to 84? Sure does. Ooh, what's half of 42? Okay. We got an odd number, so yeah, we're going to wind up with a decimal. But just do your best. And then for number 6, I did give you the final answers, so you can check your work. But it's all about showing your work on the fractions, lining up those decimals. And last but not least, old Randall, he's going to the movies. He's got $5, and I told the kids, this was a while ago, when things were this cheap at the movie theater. So we got to use this table. We got to find 3 snacks that Randall can buy for $5. And no, we're not going to take the cheap route and say 3 granola bars. That's one combination, but is that the only combination? Certainly not. So have some fun going to the movie theater, guys. Hopefully this was helpful. And again, just feel free to click around. And if you still have questions, just reach out. That's literally my job. Have a good one, guys. See you next time.